Hello friend, today I am going to take the topic Euclid division lemma. So as you are going to see how to use Euclid division lemma to find the HCF and proving the question. So let's see first talk about the what is the Euclid division lemma. It's a simple division rule that we are using from the lower classes. So if we talk about the Euclid division lemma, so you all know that suppose I am going to divide a number 25 by 3. So when we divide the number 25 by the 3, we will simply say it's a 3 8s are 24 and the remainder is 1. Now in lower classes what we are going to do, we have to check whether our division is right or not. So for the checking of division we will simply verify that when we divide a divisible number is 3. So we have divided the number by the 3 and we have read the table of 3 8 times and we are getting the remainder 1. So for the verification we will simply multiply 3 with 8 and we will add 1. Our answer should be equals to our dividend, that is 25. So you can check here 8 3s are 24, 24 plus 1 is 25. Now in 10th standard it is the same thing but written in a statement. So we always feel that whenever they something asked as a statement in maths, so we start feeling very difficult. So let's see how they are using Euclid division lemma in the word form. So as per the Euclid division lemma, there is an integer. For any integer, a and b. Now where you consider the a and b, so we are supposing that 25 is our a. So we can write let a is the dividend and b will be your divisor. So as per the statement, for any integer a and b, there exist integer q and r, or you can say there exists unique integer. Why we are using the word unique? Unique means whenever you are going to divide the number as per the example we have taken 3. So suppose we will read the table 7s are, it means 3 7s are 21, then our remainder will be more than 3. सो यूनिक का मतलब ये होगा कि कोई भी पर्सन इसको डिवाइड करे उसके पास नंबर ऑफ टाइम वो टेबल जो रीड करेगा वो हर एक पर्सन के लिए फिक्स होगा एंड योर रिमाइंडर इज ऑलवेज फिक्स व्हेन यू आर गोइंग टू डिवाइड द सेम नंबर बाय द 3 or it will be not vary as per the person. So there exists unique integer q and r such that now see when we are going to divide the a by b, we will read the table of b q time and then we will minus from the a and we will get something as a reminder. So now what we have, we will get the number a, but when we multiply b with q plus a reminder. Now as we know that our remainder is always less than the divisor and it will be equals to 0 or greater than 0. In this case when we have divided the number by the 3, so our remainder can be 0 1 or 2. That means it should not be more than 3, or it can be 0 greater than 0 but it is always less than our divisor, that is 3. So this is the simple format of Euclid division lemma. Now let's see how we are using the Euclid division lemma to find the HCF. So here we come to find the HCF of two number by using the Euclid division lemma. So when we talk about the Euclid division lemma, our first step is we have to find the least number between these two numbers, or you can say which one is less in these two number. So your 135 is less than 225. So that means our 135 will be the divisor, यानी हम 135 का टेबल पढ़ने वाले हैं और 225 को डिवाइड करने वाले. Now see, this is not a simple division. Why or how it is not a simple division? Suppose मुझे 135 को 2 से डिवाइड करना होता. So what we are going to do? It's a 2 5s are 10. Here 1. Then again we will carry the 5. And then 2 7s are 14, then the remainder is 1. Now in this division you can see that we are taking the 2 number, then we are getting some remainder, then again we are carrying the next number, and then we are again reading the table of 2. So this is the simple division. While when we are using the Euclid division lemma, in using of Euclid division lemma, we have to find the number which is nearest to the 225. It is not compulsory that we will read the table of 135 1ja, then 2ja, then again we will take the LCM, or we will carry the next number, then again we will read the table. That is in the simple division. Now in Euclid division lemma, suppose I want to read the table of 135. So I am not going to read the table of 135 1ja, 2ja, 3ja. That's it. We have to direct read the table of 135 such a way our remainder is directly less than 135. So now in this question, if I will read the table of 135 1ja, so I am going to get here 135. Then when we subtract it, we will get here 0, and then 12 minus 3 is 90. Okay, now this one is done. Now see here, we are getting the remainder that is less than 135. Suppose our remainder is not less than 135, then again we will read the table of 135 apart from the 1 2 time 3 time 4 time, but directly मुझे 135 से लेस ही रिमाइंडर मिलना चाहिए. Now this one is done. Now what the next? The next, in the first step we have divide the 225 by the 135. So now our 135 will be the dividend, and our the last remainder, that means 90, will become the divisor. Now we are going to read the table of 90 to bring the 135. So we will take 90 1s are 90, 90 2s are 180. So I am taking here 1s are, it's a 90. Then our remainder is here 1345, and then again here we are going to repeat the last remainder or last table that we have divided. It's a 90, so this side 90. Now we are going to read the table of last remainder, that is 45. So it's a 45 2ja 90. So we are getting the 0. Now this step we have to carry till the time we are not able to get the 0. When we get the our remainder 0, जब तक हमारा रिमाइंडर 0 नहीं आता है, तब तक हमें इस मेथड और इस प्रोसीजर को कंटिन्यू रखना है. सो लास्ट वी आर गेटिंग द रिमाइंडर 0. नाउ सी द लास्ट स्टेप डिवाइजर, और डिवाइजर ऑफ द लास्ट स्टेप इज 45. So this last divisor, that is 45, will be our HCF of two number. Now how we will write in the form of a is equals to, now we are going to write our divisor in the form of a is equals to bq plus r. So we will write here a means we are having the number that is 1, we have to bring the number 225 and we have taken the 135 1 plus our remainder is 90. Then in the next step here we have divided the 135 by the 90 and we have read the table 1 and plus our remainder is 45. Then again we have divided the 90 by the 45, that is 1 and our last remainder is 0. So see here, see this 45, this is the divisor of our last step, so we can write here directly that the HCF of these two number is 45. Now see what we need to write. हम जब भी यूक्लिड डिवीजन लेमा का यूज कर रहे हैं तो वेदर यू राइट दिस स्टेप और नॉट, see without this step we are not able to write directly these all step. So when you are going to write the, or when you are going to use the Euclid division lemma, that time at least you need to write these all steps, only this one will be enough. But as you know, without this long division we are not able to write these steps as a is equals to bq plus r. So now see here, there is a one pattern when you are having the less time, so you can observe this pattern. See here, when we divide the 225 by the 135, in our next step 135 will be outside and the whatever the remainder in the first step again it become the dividend. So in this is, you can simply verify that our divisor sometime become the dividend for the next step and our remainder will be become the divisor. I hope student you understand the topic very well, and still you have any doubt you can comment in comment section.